So I'm going to be teaching problem 12 for AP Physics. This is the tension problem. I've drawn it on the board. So there's a couple things I want to point out as we draw our force diagram, which is, again, where you always want to draw your force diagram so you understand the forces that are at play and in which direction they point. I also want to point out that I've replaced the actual angles with theta 1 and theta 2 just to keep it generic. So I'm not going to be solving for numbers today. I'll give you the equations to show you how it all works together, but I'm not solving for numbers because I'm limited to 15 minutes per video if I want to get it up to YouTube. So anyways, here we go. So on this mass, there is, of course, the force of gravity acting on it. And T, again, tension is just a force that's exerted along a string or a rope. So tension, even though T is not the same as F, it is simply a force. And so tension and force are really interchangeable terms. So the tension here is the thing holding it up. Now, of course, the tension on this rope goes up in this way because it's supporting it to the ceiling. It's certainly not pushing the thing downward. So it's really, really important that you actually put your arrows on these force vectors, these tension vectors, because direction is very, very important. Okay, so now that we see that these two ropes exert a tension at these angles, it's important also to now know that we're going to need to get the x and y components to that. Oopsies. The x and y components to that. So we're going to call this T2y, and we're going to call this T2x. We're going to call this y component on this side, I don't know why my hand's going all weird, T1y, and we'll call this direction T1x. Okay. So once you've done that, now it's thinking time. We got to start thinking about how do we look at the physics here to figure out what the tension is in these two ropes. The first thing we have to understand is take a look at the directions of the forces. We have some tension going this way, we have a force going this way, and we have a force going this way. Those are the only two forces in the x direction. If you notice, everything else is in the y direction. Now ask yourself, is this object accelerating in the x direction? And the answer is no. So what do you know about the forces in the x direction? Well, they must cancel. So the one thing we know for sure is that T1x has to equal T2x. And I'm talking in magnitudes. Yes, of course, they go in opposite directions, but I'm talking about the magnitudes of the forces. They have to be equal and opposite. I do want to point out that this is the same thing. You could also look at it this way if you like, that you can go T1x plus T2x equals 0. You could do it that way if you like. And then, of course, you end up with one being in the opposite sign, which is all fine and dandy, but again, in physics, as long as you understand what you're talking about, you can be a little bit more cavalier with your positives and negatives. So anyways, we know that those two magnitudes of the forces have to be equal. Okay, so that's the x direction. Well, what do we know about the y direction? Well, we know that the mass of this object is pulling it downward, the force of gravity is pulling it downward, but we also know that the combined effect of these two y forces upward are going to completely cancel this out, because we will assume that this object is not accelerating in the y direction. So we also know that Fg has to equal the combined effects of T1y plus T2y, right? Or another way of saying that is, if you wanted to, you could go like T1y plus T2y minus Fg equals 0. If you'd like to think of it that way. The zeros would indicate there's no acceleration. Okay. But I prefer this way. Okay, well, if you look here, we have two equations, four unknowns. We don't know T1x, T2x, T1y, T2y. If we could get to two equations, two unknowns, then we'd be in business, because then we could just do a substitution. So let's take a look at, and remember, we're trying to solve for T1 and T2 anyways. We're not solving for y's and x's. Well, let's take a look at this term. T1x is really just T1 times the cosine of beta 1. T1y is really just T1 times the sine of that angle. And similarly, over here, T2x is really just T2 cosine of that angle theta 2. And T2y is really just T2 sine of theta 2. Okay, and now you can start to see how this is going to unfold if you can sort of visualize your algebra. T1x is really just T1 cosine theta 1, and that force has to be equal and opposite to T2 cos theta 2. All right, I do want to point out that the thetas are given in the problem. Okay, now let's reimagine these two, or rewrite these two, and say that FG is equal to T1 sine theta 1 plus T2 sine theta 2. Okay, if you'll notice now, we have two equations, two unknowns. The only things we don't know are T1 and T2. So we can actually solve this system. So the best way to do it is we're gonna have to substitute out either T1 or T2. My recommendation is to use this equation up here. It's a little bit more easy to simplify for T1 or T2 than this one down here. So just pick your favorite. Which one do you want to solve for? It really doesn't matter. I'm going to solve for T1. So T1 has got to be T2 cosine theta 2 all over cosine theta 1. Right? I just brought this term over here. So now I can do a substitution down here. So I'm going to replace FG with MG, by the way, now, just because we have those values. So MG is equal to, now T1 has been substituted out, it's going to be T2 cos theta 2. Remember, that's still times sine theta 1, sine theta 1 all over the cos theta 1. That's what that term now looks like. And you can see plus T2 sine theta 2. Okay. Notice we have a sine theta 1 over a cosine theta 1. That is the same as tangent, sine over cosine. So mg equals T2 cos theta 2 tan theta 1 plus T2 sine theta 2. Okay, I want to point out again, we are trying to solve for T2. Well, let's factor out a T2 term. So mg equals T2 cos theta 2 tan theta 1 plus sine theta 2. Okay. All right, the algebra is not complicated. Let's just bring this whole term over here, and then we're practically done. So T2 is really equal to mg all over cos theta 2 tan theta 1 plus sine theta 2. And again, I want to stress that m was given, g is known, theta is given, theta 2, theta 1 are given. So this is all a known value. So that's just, you're going to get a value for T2. Okay. So that will take care of T2. And now we can just solve for T1, because T1 is just T2 cos theta 2 all over cos theta 1. So T1 is whatever this term is well, let's just rewrite it, I guess. Remember, this whole term right here is now going to be a number, and now you can plug that into there. And you know cos theta 2 because that's a number. So you'll be able to solve this problem now. I do want to stress that this is often how physics works, is that I would say 90% of my discussion is a math discussion right now. Right? I basically spent a lot of time on the math. In physics, the physics is almost always very simple and usually pretty obvious. In this case, think of how simple these statements are. If this object isn't accelerating in the x direction, that means that the forces in the x direction must cancel. I mean, that seems like a pretty obvious statement. So you just write it down. T1x has to equal T2x. They have to cancel each other out. That seems kind of pretty straightforward. Take a look at the y direction. This object isn't accelerating in the y direction. What does that tell you? It tells you that all the y direction forces must cancel. So the downward force must be equal and opposite to the upward forces. So again, think how easy the physics was. Once you said this, I want to point out something. This is the physics. These two little statements, that's where physics comes in. Your understanding of physics had to set up your equations. Everything else that followed was purely the mathematical consequence of the physics. There was no physics involved here. This was all algebra and some trig. The physics is pretty simple and pretty obvious. And that, again, I want to stress, that's how physics works, is your understanding of physics will set up your equations at the beginning. They'll kind of set up things that are equal or whatever. And then after that, you have to have the mathematical ability to solve what the physics says. So that's one of the things I love about physics is that the solutions or the physics ideas are usually simple, straightforward, kind of obvious, and it's the math that gets ugly. But so anyways, that's I really want to stress that on this problem. So that's problem 12 on the worksheet from yesterday. So hopefully you have taken all these notes and the iPad has recorded it correctly.